host Governor Andre Franco Monday Information India, 18 Zulu with the 022 at 7 knots. Visibility 6 miles. 4,000 scattered. 5,000 altitude is 29907. Arriving and departing runway 09 right, 09 left. While host Governor Andre Franco Monday Information India, 18 Zulu with the 022 at 7 knots. Visibility 6 miles. 4,000 scattered. 5,000 scattered. Temperature 26, dew point 18. Current altimeter is 29907. Arriving and departing runway 09 right, 09 left.
Go 1726, ready to copy.
1726 is cleared to Sierra Bravo Romeo Foxtrot. Climb via the Romy 4 departure, with the user mode transition, then as file. Expect departure runway 27 right. Climb to flight level 310 via the departure. Expect higher clearances 10 minutes after departure. Squawk 5015.
1726 is cleared to Sierra Bravo Romeo Foxtrot. Climb via the ROMI 4A departure, with the USAMO transition, then as filed. Climb to flight level 310 via the departure. Expect higher clearances 10 minutes after departure. Squawk 5015 Gold Transport S1726.
Gold Transport S1726 read back correct. Altimeter 29907 contact ground on 121.7 when ready for pushback good day.
Altimeter 29907 ground on 121.7 Gold Transport S1726.
Pre-flight checklist.
Pre-flight checklist. Oxygen.
Tested 100%.
Tested 100%. Navigation transfer and display switches. Normal, auto. Window heat, on. Pressurization mode selector, auto. Flight instruments.
Heading 297. Altimeter 1015.
Heading 297. Altimeter 1015. Parking brake.
Set.
Engine start levers.
Cut off.
Pre-flight checklist complete.
Sao Paulo, good afternoon. Go 1726, request flight level 3902 Recife.
Inbox 012, clear to 927F, wind 020 degrees, 7 knots, making 015.
Thank you, clear to land, runway 27 left, Inbox 012.
Sao Paulo, go 1796.
Go 1726, good evening, São Paulo.
Flight level 3902 Recife.
Go 1726, clear to Recife, flight level 390, takeoff runway 27 right, for mid 4 Alpha departure, usamos transition, squawk 3761.
Okay, we are clear to flight level 3902 Recife, Ramiro 4 with the departure with the USAM intersections, runway 27 right, squawk 3761, go 1726.
Go 1726, read back correct, and ground service zero discretion, camera hold point runway 27.
We California hold short runway 27 right, thank you. Okay, we have our clearance, our departure, let me check here. The chip maybe 4. (183.094). Continue to use MO here.
Então 3221, ponto para 27, direita, ponto para leste.
Então 3221, decolagem autorizada do 7 direita, vem com 020 graus, 7 nós, ajuste no 015.
Livre decolagem 27 direita, então 3221.
Go 1726. Request pushback.
1726 pushback approved.
Pushback approved. Goal transport at 1726.
Before start checklist.
Before start checklist, flight deck door closed and locked. MCP,
V2 146, heading 275, altitude 390.
takeoff speeds,
V1 140, VR 142, V2 146.
CDU pre-flight,
Completed.
rudder and aileron trim,
Free and 0.
taxi and takeoff briefing.
Completed.
Are you sure?
Yes.
Anti-collision light on. Before start checklist complete.
Nose left.
Cockpit to ground. Go ahead. We've been cleared for pushback and start. They want the tail to our right. Copy that. Ready to push. Tail to the right. Parking brakes release, please. Brakes released.
The start sequence will be 2 then 1.
Brakes released. Here we go.
Start engine 2.
Starting 2. Starter cutout.
Start engine 1.
Starting 1.
Pushback complete. Parking brake set. Brake set. Steering pin is pulled. Watch for the salute and release from guidance.
Essa identificação mantém o nível de voo 370. Carenado está embarcado no voo.
Starter cutout.
Flaps 5.
Flaps 5.
5 controls check.
Ready.
Full left. Center. Full
Check.
right. Center.
Check.
Full up. Center.
Check.
Full down. Center. Rudder.
Check.
Full left. Center.
Check.
Full right. Center.
Check.
Flight controls check completed. Go 1726, ready to taxi.
Aircraft calling ground, say again with your call sign.
Go 1726, ready to taxi.
1726 taxi to runway 27 right via taxi was Golf, Alpha, Hotel, Bravo, Papa, Quebec, hold short runway 27 right.
Taxi to runway 27 right via taxiways Golf, Alpha, Hotel, Bravo, Papa, Quebec, hold short runway 27 right Bowl transport at 1726.
Before taxi checklist.
Before taxi checklist, generators on, probe heat on, anti-ice off, isolation valve auto, engine start switches continuous, recall
Check it.
checked, auto brake, RTO, engine start levers,
Idle detent.
flight controls,
Check it.
ground equipment
Clear.
clear. Before taxi checklist complete.
Taxi lights on. Let's go. Header terrain before takeoff checklist. Clear left.
Clear right.
Before takeoff checklist.
Before takeoff checklist. Flaps.
5 green lights.
Stabilizer trim.
5.5 units.
Before takeoff checklist complete.
We have light winds here in São Paulo, so because of this, the traffic is going to runway 09.
Flight deck. Okay, thanks. Captain, the cabin is secure.
Thank you. Can wait a little bit.
Bruno 941, controle Natal, frequência 119, decimal 3. KLM 705, contact Andes frequency 1, before decimal 9, or make them 1 to 5 decimal 4.
Springbok 326, 1 at 54, vacate runway, cross 09 left, after cross, fast your discussion.
Vacate to the right, cross runway, 09 left, exit, my discretion, 0156.
Code 352, direto do loop.
Direto do loop.
Então 3221, serviço da escada 55, FSLABS.
228, graças a Deus,
Boa noite, detenidor de voo 170.
Voo 1333, após invadir a federal. Sente, voo 1333.
Oh, 1726, ready for departure.
Tower on 118.4 Goal Transport S17.
Oh, 1726, ready for departure.
1726 winds are 022 at 7 knots, cleared for takeoff. Runway 27 right, squawk 5015.
Cleared for takeoff. Runway 27 right, squawking 5015 Goal Trans.
Aircraft calling Sao Paulo Control on 134.9er. It appears you may be on the wrong frequency.
Sao Paulo, go 1726, ready for departure, 27 right.
Go 726, clear to take off runway 27 on left, correction 27 right, wind is 020 degrees, 7 knots, Canadian 015.
015, clear for takeoff, 1726. Runway entry procedure.
Check. Cabin crew, take your seats.
Go 1333, desce uma centena.
Clear left.
Clear right. Ready to go.
Takeoff.
Check.
Centro Recife, 34,9, equipagem 23,4.
50%. All bottom motors are stable. Toga.
Check.
Speed alive.
Thrust set. 80 knots.
Throttle hold.
Check.
V1.
Rotate. Positive rate.
Here, I'm
Go on 726, radar contact on departure, climb no resistance to flight level 390.
Command A.
Check.
Select Command A.
Command A.
Okay, flight level 390 Delta, go
Full transport at 1726, contact tower on 118.4.
Contact tower on 118.4, goal transport at 1726. Tower goal transport at 1726, climbing to flight level 310.
GOL transport S1726, good
Flaps
afternoon.
1.
Squawk
Flaps
5015.
one.
Flaps up.
Flaps up.
GOL transport S1726, contact Brasilia Center on 126.15. Have a good one.
Center on 126.15, goal transport at 1726. Center goal transport at 1726, climbing to flight level 310.
Goal transport at 1726, good afternoon. Squawk 5015.
Squawk 5015, goal transport at 1726.
Clearing the restrictions.
O voo de 3-2 confirma, vai manter o 310 como final dele.
After takeoff checklist.
After takeoff checklist. Engine bleeds. On.
Ah,
Packs.
negativo,
Rudder.
352.
Landing gear. Up and off. Flaps. Up. No lights. After takeoff checklist complete.
Center on 126.1, goal transport at 1726.
Nível 270 aprovado com manobra final, mantém o mesmo reporte para destino.
Center goal transport at 1726, climbing to flight
release
level
the
310. Goal transport at
Okay.
1726,
10,000.
good afternoon.
Okay.
Squawk 5015.
Squawk 5015, goal transport at 1726.
Goal transport A 1726, descend and maintain flight level 090 until passing Echo Golf Delta Uniform Papa.
Descend and maintain flight level 090, goal transport at 1726.
Goal transport A 1726, contact Brasilia Center on 126.15, enjoy your afternoon.
Center on 126.15, goal transport at 1726. Center goal transport at 1726, climbing to flight level 310. GOL transport 1726, good afternoon. Squawk 5015.
Voo 439,
Squawk
voo controle
5015,
São
goal
Paulo,
transport at
chame controle apenas
1726.
participando por Anise.
Mas assim, vai ter que passar por ali e forçar.
Voo no 333, desce direto 7.100 inscrições, ajuste no 015. Autorizado high speed número 1, autorizado LSO, teleporte na final.
7.000, autorizado com ajuste, autorizado LSO, teleporte na final.
1726, fly direct to Usama intersection.
Flying Usama 1726.
Goal transport at 1726, contact center on 126.15.
Confirm
Contact center on
execute.
126.15,
Confirm.
transport at 1726. Center goal transport at 1726, climbing to flight level 310.
GOL transport 1726, squawk 5015.
Squawk 5015, goal transport at 1726.
K1 702, reach center, meeting for level 370. Brava 748, está em nível de voo no 00.
Someone else is...
Roger, Mark point 83, so call code Fox Mike Alpha Juliet. Roger, thank you. Conecta 5195, centro Recife.
Transition altitude set standard.
Standard set. Set standard.
Standard set.
And as our software engineers are also part of our engine development team and chassis development team, they consider aspect, maybe I should have this function for this when I'm driving the car with this chassis setup, I should maybe put this in. They're kind of thinking more as a whole, which is completely unique. If I'm guessing, I would say maybe we're spending 15-20% of our development time and budget on stuff like this, something like that. But it's all integrated in the other items as well. It's definitely the brain, but it's part of the soul. I mean, it is the brain, but it gives part of the soul and the experience. Because this is really the controlling function of the mechanics.
Every single line of code inside the ECUs have been written by us, and also this software that we're using in the PC is also entirely written by us.
It's a never-ending story of evolution. It is exactly what Matthias said. What is your biggest challenge? It's time. Because if you had all the time in the world from the get-go, you would never have to update software. Because you always come up with new ideas, there are new systems in the car, customers ask for new features, and there's just it's an endless possibility to come up with new ideas and improve, basically. And for sure we do that on service for the cars, and also upgrade older cars with newer hardware systems so we can put new software into them, if the customers want it. I mean, they're fine as they are, but you can get new features, new experiences if you do. My name is Christian von Koenigsegg. Our latest car, their symbol
My name is Robert Servansky, and I'm the test driver of Koenigsegg. My job is basically two parts. I develop the cars, how they handle and performance-wise, and I also am a part of the production line. Production-wise, I get a assembled car in one piece, you could say, and then I finalize it. Finalizing means I do the wheel alignment, I bed in the brakes, bed in the differential. I'm with the guys who tune the engine properly. Everything is assembled by hand, so there are of course small differences in every car, and that's why we tune every car to a specific setup. And we do a few wheel alignments, so everything can settle down. And once everything works properly, we also check quality of the car. Of course, every function and every feature of the car must work. And so nothing can rattle, nothing can sound in the car. And we do a lot of driving, and we drive the cars rather hard because they need to work once they get to the customer. And a lot of that work is done on this runway.
Easy money.
This is a specific car. We did the 0 to 300 to 0 record in. I was in 21.19 seconds. That was a year ago. It wasn't this cold and not this windy, and so of course it was better for the performance of the car. And also right now in the videos you saw, we only run on 50% bioethanol. And in the record videos, we obviously drive 85%, which is available at a normal petrol station in Sweden. The car was just taken out on the day. Christian gave me a call and said, shall we do a test to do the record? And we collected some equipment, got out here and just did it, basically. It was just sort of a stage in the verifying process of producing the car, really. They gave me a call about 2 years ago and offered the job. And I came here and had a few hours of discussion with Christian, and we talked about what the job was about. And then obviously there was a testing period of where we went all the job through and what's supposed to be done and how I feel about the car, and I'm still here. A day could be everything from driving for 12 or 16 hours, and it could be changing an engine or a gearbox for development purpose. So there's not one day that is the other day like, and that's a good thing about the job because you never get bored. Well, my tools are basically, it's also depending on the purpose, obviously. Right now I work a lot with the gearbox. We have our own gearbox management, and for that I have the engineers, and I have a computer and a car. So, and also we need to tune the gearbox for driving in the city or on highway or doing 0 to 300 to 0. So if I need to tune the gearbox for driving in a town, I obviously drive in a town. And that's of course doing 50k and not 200. So everything is through one cable, through OBD, is simply, is accessible through one program, one cable, one interface. So everything, I choose what I would like to see and what I would like to adjust. If I would like to go to a certain gear, for instance, I have the behavior of a gear, the clutch, the shift time, the torque cut, everything we control. And everything can be logged while we do it. It's also the same thing here, even though we have thousands of parameters. There's no purpose of really seeing all at once because it would look something like this, and it's just looks messy. And I can connect that what I see in the log to what I sense, and I can see that, for instance, okay, this clutch closes a little bit too fast, or we don't cut the torque fast enough, or whatever I see or sense, and then I change it, and then I drive again, try. So it takes a really long time to adjust because you have a range of 1,000 to 7,000 revs, you have 7 gears, so it's quite many cases to solve and get really good. It's a combination between man and machine, really. I think that we hope to do, well, we want to do the best car in the world, basically, and I think we're on a good way to do it. It's a very extreme car in all ends, but you can really put your grandma in it and just explain the pedal function if she doesn't have a pedal car already, and let her drive, because it is really that easy to drive. Of course, we're on a good way to do it. It's a very extreme car in all ends, but you can really put your grandma in it and just explain the pedal function if she doesn't have a pedal car already, and let her drive, because it is really that easy to drive. Of course, it's wide and it's low and all those parts, but it's really easy to drive. And of course, when you start pushing it, I think you need to be, it will not kill you, but you need to know what you're doing to really be able to enjoy the car fully out, because that is when it really comes to its soul, or whatever you like to call it. Comes alive, correct. You can still have plenty of fun just driving along, hitting full throttle and full brake and turning, but it's a really refined tool. A lot of engineers prior to my time and during my time, and also what I have done with the car and all the other people, there's a lot of effort put into it that it should be very perfect in its behavior. So we actually enjoy when people use the cars, because that's what they are meant to do, to use them. Yeah, we don't usually do drifting or sliding for the purpose of sliding, but that could be a byproduct of testing something else, of course. And when we test, we do a lot of testing on the limit for the car to, for instance, prevent a behavior of the car breaking out or spinning away too easy. And then we need to go past that point to really tell what would happen and how the car behaves.
1726, contact Brasilia Center on 124.8. Have a good afternoon. Center on 124.8, Gold Transport S1726.
So we do all the adjusting and behavior and how we would like the car to feel is done without anything. And then we put ABS on, we put the electronic differential on, we put the stability control on. So we only have those, as you know, as your safety line, or whatever you'd like to call it, to prevent nasty things from happening. But if you would take everything away, we believe that the car as it is would be very enjoyable for an experienced driver. No, you can be a good racing driver and not be a good test driver, and also the other way around. Because the race driver is not always about feeling the car 100% or putting very good lap times. A race driver can be at the top because he knows how to fight his way through the field. And he has a good pace enough to keep that first place. But that doesn't actually mean that he needs to be the fastest if he would go to a time attack. So that's also the difference, that you must want to learn what is happening. And of course, an input that something is understeer or oversteer might be good enough for an engineer, but if you can tell the engineer that it's understeers, but it's at the same time it's too soft, maybe we should check the springs or the anti-roll bar, so not just understeer, because understeer could be, well, a lot of things. So I think, well, it's always about the good compromise, really, that you need to have.
And having fun.
And having fun, that's important. You can never forget to have fun, because that's important.
I'm 40 years old, and for half of my life I've been on the quest for fighter jet squadron. So the interior of the car is as important as anything else we do. We spend a lot of energy and time to optimizing and making it really special and unique and functional, of course. I mean, this is the place where the driver, owner and the passenger spend most of its time, so it's important that you feel really special inside the car and that it works well. So I'm going to tell you a little bit about our ghost lighting system that we developed for the Agera. Basically, we wanted something elegant, clear, unique and ergonomic and nice for the driver and the occupant to be able to control the car and its function in the best possible way. We thought it was pretty cool if we could have a metal button, an aluminium button, which just is smooth and nice and you don't see or feel anything until the light turns on, and then it shows up what it actually is. And we had to spend a lot of time to get the lighting correct, to have it shiny enough on the inside, to have the surface thin enough so that the light can penetrate through the very small etched laser holes. And the holes were optimized in size so that they're hardly visible when the light is off, but very visible when the light is on. Also, we have a philosophy that inside the car, basically the only materials you can touch is either leather, carbon fiber or metal. There's no plastic anywhere. Here is the circuit board going behind, and we actually have lighting here, but also 4 small LEDs, very strong LEDs inside each button. You see this one is naked, so this one goes like this and moves together with the button. Then they're all spring mounted on this very unique circular spring, which was developed. We used a special spring steel with a certain thickness and a certain shape to get the right spring effect going, to have a really nice click for each button. So we mimic the same kind of features on the steering wheel. First of all, of course, it has to be manufactured in carbon fiber, baked in the autoclave. Then it has to be clear coated in the paint shop. Then we put the foam agent underneath the leather, and then the leather, and that's about a one-day process just to apply the leather. And then we have to fit all the electronics and the paddle shifters and circuit boards and make it into what it is. So the steering wheel is one-piece hollow carbon fiber that we designed here, and it's very optimized to the interior of the car. It's a little bit thinner up top, so it's easier to see the instrumentation. It's got a flat bottom to make it easier to get in and out of the car, and it's got an optimized grip section. Also underneath the leather there is a foam agent to make the steering wheel more compliant and to take out some high frequency vibrations that it's not, that dilutes the input from the road basically. Here we have also ghost lighted buttons. As you can see, they're just shiny aluminium until the light comes on. And this goes into the steering wheel here, one on the left side and one on the right side. And there's a lot of functionality and processing going on in the steering wheel. So we actually developed a circuit board for the steering wheel which has CAN bus communication, a CAN bus protocol going through just a small amount of cables. The reason why we have CAN bus in the steering wheel is to reduce the amount of cables that has to go through the axle and that has to spin around all the time when you're turning. But it also gives us flexibility to have different functions for the buttons. We can change symbols and change software, and then we have a completely different function without rerouting cables. Another thing which is very important is that we have these shifters mounted to the steering wheel, and we spend a lot of time making sure we have the right click feel. So it's like a trigger basically. It's either on or off, you can't press it halfway. And it's also important that it has a solid mounting base. If you want to press it by the tip, it doesn't flex at all. And they're very long for being steering wheel mounted, so you get very good ergonomics when you're turning the steering wheel. But most important is how they feel, that they have a really nice trigger feel click to them. So there are several different spring elements inside the shifter to have the right feel. All in all, it's a a very unique product, the steering wheel with all its functions. And I would say normally it would take almost the size of our company just to develop a thing like a steering wheel, but that's something we just do on the side. And of course, final part is the airbag that goes in. So it's a quite complex product, the steering wheel alone by itself. Here we have an aluminium part. All the aluminium parts inside the car are machined from billet aluminium. And you can see here on the back side there are some traces of machining. On the front side, of course, the machining time is much longer and slower to make it really smooth. After it's machined, it's polished in a special polishing machine. It's not just tumbled, it's a proprietary polishing system which makes it extremely smooth. And after that it's anodized to get a good surface protection. And this is the process that all the aluminium parts in the interior goes through. Former Swedish. The first thing you see when you see any car, and especially a Koenigsegg, of course, is the outside of the car. We actually do all our painting of the carbon fiber pieces here in-house to make sure we have full control of something that is very critical. There are so many different ways of applying clear coat or paint to a car that we really feel that we want to control that process, as it is an integral part of what the car is. So this is our body pre-fit station prior to that the panels go into the paint shop. Here we make sure everything lines up perfect. If you look at the front of this car, it's going to have a clear carbon center section, but here it's going to be paint, so you can actually see different types of carbon fiber depending if it's going to be visible carbon or not, as we don't want this kind of heavy fabric weave underneath a painted surface, because it can give print through the paint over years of time. This is actually chassis number 99, and over there we have chassis number 100. So we're very happy that we're getting to the point of almost having built 100 cars. It's not far off. A lot of the work in the paint process is about masking, making sure you don't get paint or clear coat where it's not supposed to be. Especially if we have these more complex body parts with clear coat carbon with pinstriping on and so on. It's probably the most time-consuming part is the masking process. On and off many times on each panel to get all the different layers, colors and schemes onto the parts. So what we're seeing here is this hand cutting of masking tape. Here we can see a rear bonnet in process, so it's all masked up. You can see these vents here are all covered because they're going to be clear carbon fiber, also the center part here. This here is also clear carbon fiber, while this is a solid white paint that's going to get sanded down a little bit, and then another layer of, well, the finishing layer is actually a pearlescent layer to get a deeper, more interesting effect of white than just plain white. So this is probably halfway through the process right now. One important reason for a car that it's a collectible item or that will last for a very, very long time and many years is that you have a durable paint finish. And I would say also that the clear coat layer on top of the paint is thick enough to take a lot of polishing and rubbing and buffing without becoming too thin over time. So the clear coat layer on our car is about 150 microns thick, which is about 3 times thicker than you would find on a normal car. What that enables is that when we polish the car here, we can already make it a really nice flat finished surface with basically no orange peel whatsoever. Let's say large car manufacturers, they're happy to build in a little bit of orange peel to make sure that any imperfection underneath the paint does not, from the panels, does not show through. It's kind of hidden with the orange peel effect, but we don't want any such excuses. And we spend the time basically to flatten the top surface of the clear coat to get the kind of wet look. And as the clear coat is so thick, it's also very deep look. To have this amount of clear coat on a car actually adds a little bit of weight, which we're very wary of. But still, it's I would say it's weight in the right place, and we're only talking 1.5 kilos in total to have this type of finish compared to a standard duller finish with orange peel. And this particular car we're looking at is one of the more extreme ones, as it has actually a visible carbon fiber skin through the clear coat. And not only that, the clear coat is tinted with a green tint. And not only that, actually, it's even multicolored, because here we have the kind of the normal carbon fiber look with just a clear coat on top of it, and here we have a tinted clear coat, and in between we have a pearl effect stripe. And what's pretty amazing is that these layers are of course done step by step and at different times to get this effect. And still, when you feel it here, there is no step whatsoever in the surface. And to get that kind of result with these different colorings and layers and inlays of colors without having any kind of side effect showing up, takes a massive amount of work. So just polishing all the parts in the car after paint or during paint, actually we have 7 layers of clear coat, but this whole polishing process is about 200 hours per car. So it's pretty extreme. Utilize old hangers of a So here we are at station 6 out of 7 on our production line, and I'm going to talk a little bit about our rear suspension on the car. If you want a car to go fast, and especially on the track and in cornering and braking, all of these aspects, it's not enough with a powerful engine. You also need a chassis and a suspension which is up to snuff to get the power to the ground, really. So here when I open this, you can see what we call the triplex suspension. First of all, it's very unique, and it really enables our car to get maximum traction, maximum level of comfort. This is actually a road car as well, but with very little compromise between comfort and handling and stability. It's basically one extra shock absorber connecting the rear wheels together. They have one shock absorber each here going down into the chassis with the spring holding the car up. But then there's this extra shock absorber tying the wheels together. And underneath here you can see our quite unique Z-shaped anti-roll bar. So the reason why we developed this third damper connecting the sides together is that we were getting so much power in the car that we were getting more and more squat during takeoff, which in one way is good to get traction, but you don't want too much movement in the car, so it's easy to handle and that it's stable, but you still want a lot of traction, of course. Most manufacturers solve this need by changing the geometry of the suspension so the car can't squat due to geometric restriction. The backside of doing that is that it dilutes the geometry that you need for cornering and the other parts of handling. In a way, it's an anti-squat damper. It means we can have a truer suspension geometry than otherwise. On top of that, it has other side effects, as it is a new dimension of dampening where you have forces going from one wheel to the other. So for example, if you're driving on a road which is a little bit uneven from left to right hand side, you have independent movement of the wheels, which is good. But then you have the anti-roll bar, which is there to stabilize in cornering, which you rather not even have while driving straight on a bumpy road, as it makes the car feel a little bit less comfortable than without it. But what's interesting is that this damper actually counteracts the forces of the anti-roll bar in that situation. So when this wheel moves up on a bump, and this is not hit by a bump but you're still driving straight, this link here pushes the anti-roll bar this direction, pulls a similar link on this side that direction, and wants to lift this wheel up as well, which causes on all cars with anti-roll bars a certain amount of harshness. But when that is happening when driving straight on the road like that, this shock absorber actually sends a force to this side of the wheel, counteracting the force of the anti-roll bar, cancelling that energy out. So you get the same or similar type of comfort in a straight line as if you did not have an anti-roll bar, which is a great side effect. Also, the damping curves of this shock absorber are very, very special. Basically, it's focusing on low speed damping force. So when you get high speed, when you hit something harsh and fast, basically it's not doing much. It's more for the lower speed dampening where it's efficient. So there are a lot of different philosophies that can be applied and that we can enhance in the future. But the starting point is to reduce squat, increase comfort, and reduce roll by the fact that we can have a stiffer anti-roll bar than we otherwise could have without it. Now at the front of the car we can see we have a similarly complex suspension layout, and actually here everything is very, very low to have, again, as low center of gravity as possible. But also we needed to make it low to be able to get our roof into the car, which is a very unique feature. So we couldn't have anything in the way for the roof to slide it in here. But it had the side effect of actually also lowering the center of gravity. So that's a perfect example of two needs working together without compromise. Extreme upright technology, extreme brake technology. All of these systems combined made it possible for us to take the world record from 0 to 300 to 0 kilometers per hour. It's really all the systems working together. If one of the systems like suspension or brakes or engine or gearbox weren't up to the task, we could not make a record like that. So it's all systems working together, putting the power to the ground, creating stability, creating traction and braking power. It's Swedish design. Carbon fiber is really one of the fundamentals really to make a car strong, very light, safe and have fantastic performance. It creates massive rigidity but does not add weight, which is crucial if you want to make a really efficient, fast and fun sports car to drive. As far as we're aware, our cars are the most carbon fiber intense cars in production right now, as we have over 400 different carbon fiber pieces. This here is an intake for the engine, intake plenum. We have some pressurized turbo pipes, valve cover, and even parts like the engine, as we can see here, are made of carbon fiber, especially the parts up top on the engine to get the center of gravity low. So what we're seeing here is something as very simple as a tube. It's a turbo piping, And what I have in front of me here is a machined mold from aluminium. Even a simple detail like a tube needs a lot of thought to make it perfect. The CAD model is flow to check that the flow is perfect, that it has enough volume to pass enough air to the engine at top power levels and top RPM levels. It also has to have a shape which is strong enough and a calculated thickness of the carbon fiber so that it can take the boost pressure. You can see here that it's kind of a funky shape to it, that it's flow optimized for this curve. We have an integrated mount here for a pressure and temperature sensor. Actually, when we manufacture a carbon fiber part from this tool, the first thing we do is to put a release agent here, because in the carbon fiber prepreg, which I have here, which is actually the material the part is made out of, it's pre-impregnated with the two-component epoxy. So if this would be put down here without a release agent, it would actually stick to the tool. And then this material, the carbon fiber, is cut to suit the tool part. This is not optimized for this now, I just took a small piece, but it's applied like this, layer by layer, different amount of layers depending on the need. So that's actually what's going to become the part. Then we need to pressurize. We need heat and pressure to consolidate this, to get it to have the right strength and the right properties. So in order for the rest of the process not to get processing material not to get stuck into the carbon fiber and the epoxy, we put this kind of release film here, which is easy to tear off of the part when it's done, and it also makes sure that this breathing fabric, as it's called a breather, doesn't stick to the carbon fiber piece. And what this does, it makes sure that the pressure that this is subjected to, or the vacuum that we also suck out, that it gets spread out and that we don't get pockets of air. It's making sure the atmosphere difference is controlled over the surface. So at the end we put this bagging material over the whole part, and then we seal it off with kind of a goo that is similar to black chewing gum, I would say. So basically these are the elements included in the production of the part. And it's quite intricate, especially with a tube like this that has to then, you put carbon fiber here, we put carbon fiber here, and then these, I'll take this out right now, then they have to match together. And we need this bagging material to come into the tube to pressurize the tube from the inside and then to seal off the tool from the outside. Of course, the thinner, the lighter, but also less strong part. So if it's a safety critical part, or like this, a pressurized part, it really needs to be calculated well to have the right amount of carbon fiber. You never want to put more carbon fiber than you need into a part, because first of all, carbon fiber is expensive, so the part becomes unnecessarily expensive. It takes more time to apply the carbon fiber than is actually needed. And in the end also the part becomes heavier, which is maybe the worst part in a super light sports car. The end result is this tube. So in the end it's a quite simple looking part, but there's a lot of thought that has gone into what it becomes in the end. Already of course from shaping the part, but also when it comes to laying it up and getting the right consolidation. You can see straight from the tool you get a quite nice even surface that doesn't require a lot of hand fettling afterwards. As it is a very complex technology, there are many types of weaves, many types of carbon fiber strands, and different philosophies how to apply them. It's a little bit of a black art really, and really lessons learned and what kind of philosophies you're working towards. But we have been developing carbon fiber parts since 1994, so I would say we have a quite good experience and can create extreme lightweight and strong parts based on the knowledge we have and the analysis tools we have. So it's really a labor-intensive process, and the persons involved in the manufacturing really needs to know what they're doing to get the desired result. course here we have a much more complex part, so you can imagine what has to go into this compared to a simple tube. And what's nice about carbon fiber is you can vary the strength and thicknesses in different areas with no limit. It's just how much thought you want to put into it, and how much labor you want to put into it. But it can be so optimized, like this corner can have a little bit extra carbon, it can be thinner here, we can have a different direction. Not many other materials gives that kind of freedom. At the same time, not many other materials can soak up so much time in the production process. But that's what makes the car extreme and what it is in the end. Koenigsegg and carbon fiber are very closely integrated, and it has to be that way in this very competitive market we're in. Goes into them. Marketplace, you really have to
Feliz ano novo e que Deus elimine vocês.
3016, sub mantenha nível 340.
Aerosan 3016, gráfico.
Voo 9182, desça ao nível 110.
Faixa 190 para 340 restrito.
025 Recife, sub mantenha nível 340. TAM 3028, chame 125 decimal 4, alternando 34 decimal 9. Recife, submantenha nível 3.0, sob veturação para as próximas tráfego, mantenha presente proa por mais 50 milhas após o índice.
Falou, Sargento.
1827, agora afastado 47 milhas sudoeste de Maceió, foi direto Indes. Uma hora, 68 milhas, passando 2 horas, 67 milhas, rumo oposto, passando no nível 320 para 110, Bravo 732.
Gold Transport A1726, contact receiver center on 125.45, enjoy.
Center on 125.45, Gold Transport A1726. Center Gold Transport A1726 at flight level 390. Center Gold Transport A1726 at flight level 390.
GOL Transport 1726, good evening. Squawk 5015.
Squawk 5015, Gold Transport A1726.
TAN 3012, nossa frequência para 133,65.
GOL Transport 1726, radar contact.
1345, TAN 3012, graças. 3012, agora 3365.
3 horas, 16 milhas, rumo sudoeste, nível 360, Bravo 738.
Centro Recife, boa tarde, eu vou no 877, passo no 85 ao 360.
Centro Recife, mantenha o nível 340 Recife.
Solicita nível 380. Aguarde.
2, tráfego, 1 hora, 3,4 milhas, rumo oposto, passando o nível 260 para o 380, Bravo 738. Gol 2290 para frequência para 133,65, alternando 34,5.
Isso, Gol 2290, mantém 360.
Recife, mantenha nível 360, tráfego 1 hora, são tráfego 12 horas, 10 milhas, rumo oeste, passando nível 300 para o 340, Alfa 3. Alfa Tango, Kilo, Papa Vitor, Centro Recife. Tango Victor, Kilo de Alta, Centro Recife, confirme. Rádio Distância Salvador. Então, Vitor, se eu dessa, confirme se transporte de órgãos e enfermos. Vitor, se eu dessa. Confirma Nacional no centro. Voo 175 Centro Recife, que mantenha nível 380. Comandante Vitor Senhor da Guarda. Voo 1877. Voo 1877. Informa o tráfego 3 horas, 2,1 milhas, rumo convergente, nível 360, Bravo 738. Voo 77, mantenha nível 340.
Esquece, Fabio 340, restrito, voo 187. Boa tarde, Gol Noite 79, passa 170.
Tango Vitor Kilo de Alta, Distrito da Critério, não há tráfego a informar. Informar. Bom. 79, Centro Recife, submantenha nível 360, Gol 1879.
879, voz 9, passou 780.
Gol 2290, em tráfego. Gol 2290, tráfego 9 horas, 1,6 milhas, como convergente, passando no nível 320 para o 340, Bravo 738. Voo 982, chame Maceió em 128,9. TAM 3012, submantenha nível 360, TAM 3012.
Gol no 879. Agora o 220 pro 360, voando nosso. Voo 1879. Subiu, mantenha nível 360, voo 1879. Um 879, voo direto, posição SEC, Serra, Eco, Golf Delta Oscar. Muito boa tarde, Azul 4148.
Azul 4148, Centro Recife, me mantenha nível 380.
Oi, poderia voar na Projetaro?
Centro Ataro, Azul 4148. As próximas 50 milhas.
Não, 3012? Negativo, senhor, sem previsão de desvio.
2, voo 1877, tráfego ultrapassado, subiu, mantenha nível 380. Mantenha nível 380. Voo 1773 Centro Recife, contato radar 30 milhas sul de Aracaju, submantenha nível 380. Voo 9194, chame controle Recife em 120.4.
GOL Transport 1726 expect the ILS approach to runway 18 with the RF011 transition at Air Desert in. Expect the ILS approach to runway 18 with the RF011 transition Gol Transport S1726.
Bruno 875, prossiga.
Comanda 240.
Tem direito 270, 40 milhas. Autorizado Bruno 875, após direto no núcleo.
Tá confiando?
Direto no núcleo. Mike Uniforme, November Uniforme X-Ray. O 3092, Recife. O 3092, Centro Recife, no 25.4, secundário no 34.9. Azul 4688, Recife, boa, sua identificação, submantém nível de voo 360.
Submantém 360, Azul 4688.
Oi, 75, Recife. Recife, na 25,4, secundária na 34,9. Zona 773, de Recife, em 125,1, secundária 123,8. Recife 27, Recife. Boa noite, 27, de Recife, no 25,4, secundária no 34,9. Fazendo 84, passengers, welcome to climb in flight level 370. Centro. Boa noite, 77, chama o Centro Recife, no 25,4.
GOL Transport 1726, descend and maintain flight level 300. Descend and maintain flight level 300, GOL Transport S1726.
4688 Recife.
Vira para o 4688.
Azul 4688, vou direto Remig.
Confirma a posição Remig, intensidade 1 na frequência para o 4688.
Azul 4688, afirmo, vou direto Remig.
Direto Remig, 4688.
Pro 9, Recife, boa, sendo identificação, submantém o nível de voo 380. Fazer 84 Recife. Wait. Bravo, Romeo Echo, just for check. Voo 4119, Centro Recife, boa, sua identificação, submantém nível de voo 380.
Azul 4682, passa 167, atenção 360.
Centro Recife, boa, sendo identificação, submantenha nível de voo 260 restrito.
82.
Gol 4119 centro. Gol 4119 Recife. 4119, sabe quanto tempo atinge o nível de voo 380? Gol 4119. (4035) Centro Recife, boa, pela identificação. Sub e mantém nível de voo 240 restrito. O azul 4035, veteração para separação de tráfego, curva à esquerda, corrigindo, curva à direita, direita proa 0 no 0, repostabilizado.
Direita 0 no 0, reportará.
Zero. Nível de voo 380.
Cita o final 360, o 4035.
Gente, azul 4035, sub e mantém nível de voo 360.
360, mantendo a proa 0 no 0.
O azul 4035, seu limite nessa proa será de 35 milhas. Em caso de falha de comunicações, após o limite, reassuma a navegação, vá direto de Ana.
35 milhas de Ana.
Recife. Azul 4682, é autorizado a subida a nível de voo 280. Vai fazer 84 Recife. Fazer. Azul 4688 Recife. Azul 4688, me chama em 126 decimal 85, secundária 125 decimal 45. Azul 4035, reassuma a navegação, vai direto de Anos.
4035.
Do 4688, mantém nível de voo 360. Voo 2290, chame o Centro Recife no 25.1, secundária no 23.8. Obrigada.
Recife, boa noite, azul 4333, pesado, passa 170 ao 400.
4333, Centro Recife, boa, sendo identificação, suba e mantenha de voo 400.
4333.
Autorizada a subida a nível de voo 300. Décima 8. Voo 4119, suba até nível de voo 360 restrito. Voo 4117, Centro Recife, sua identificação, sub e mantém nível de voo 360.
Prossiga.
Tá nível de voo 340. Gol, passando 350 em subida ao 370, Bravo 789. Chegou 4117, mantém nível de voo 360. Posicional agora 3 horas, 30 milhas, com rumo sudoeste, nível de voo 360, Alfa 2190.
82. Azul 4682.
82, prossiga.
Solicita conta possível, nível final 380.
Conta 340 e aguarde. No 9 Recife. Voo 4119, chame o centro Recife no 26,85, secundário no 25,45.
We are near the top of descent. Aurelio in this Recife, runway 18, auto brake 3.
05, passa nível 185 para 380.
Aeronave de categoria Alfa, categoria nave. Nenhuma outra observação a respeito do pouso lá. Cartas do DCEA.
05, nível 190. Centro Recife, boa noite, Azul 4499, passa 158 ao 200.
A gente tá chegando aqui por Aracaju, Buvade. Aliás, por Aracaju, Buvade, descendo então 070 e 3.000 pés no Romeo Fox 011. Aproximação final vai ser
Checked.
Whiskey. Are you ready for the approach brief?
I'm ready for the brief.
Aproximação ILS Whiskey da 18. A descida vai ser até 223 pés. 223. Prontinho. Só dar um save aqui. Caso de aproximação perdida, a gente vai subir para 3.000 pés, manter a proa da pista Model 4, após 2.000 pés, está livre para curvar à esquerda para o Romeo Vorox 009, 3.000 pés. 110-30 o localizer. Flaps 30, F143. Any questions?
None.
Descent procedure?
Check.
Descent checklist.
Descent checklist. Pressurization. Landing altitude is 50 feet.
Correct.
Recall checked. Auto brake level 2. Landing data.
VREF 143.
VREF 143. Minimums 0 feet. Approach briefing.
Completed.
Descent checklist complete.
Descent to 3000.
É o Gol 1727, boa noite.
Final approach course.
Check.
Ficou 360, Gol 1727.
Aerosoft A32F, center, smoke identity plus level 370.
Altimeter, destination 1013, auto brake 3.
4035, vou direto para o 376.
After landing runway 18, taxi located via Lima, apron 2, position 12 or 11. 11 or 12. The next one that is probably available. We are beginning our descent. Load the forecast winds. Execute. Confirm execute. Confirm execute. Confirm execute.
Confirm.
Let's check with the navigation. How's the weather?
Checked.
Weather report. Just to make a comparison.
Checked.
256 0350 250 250 K22 150 6 with 313. Not so much, but it's okay. 140 with 12. That is much nearby. For descent, Aracaju 150054.
Azul 4035, Recife. 4035, chama no 35, decimal 25, secundária 125, decimal. Para que eu precisava falar de noite, eu tinha que 0 graus, era 99.
I have Homer Fox 11, 190, the indicator speed.
Roger, that is the case.
190 below. Okay, everything's set. Go 1724. Go 1726, request descent. Go 1726, radio check.
1726, this is Brasilia Center on 126.15, please repeat your request.
Go 1726, request descent to flight level 150.
Checked.
Medicamente.
1726, request flight level 060. Não vai autorizar.
Já tem falado com 8, eu estou no espaço cerebral 069.
Passageros for informar number em seu concurso.
Azul 4430, passa nível 170 para o 380, boa noite.
Mark numbers is out in one area.
Perdão. 360 inicialmente. Aqui, ó.
Ali uma pessoa.
GOL Transport 1726, contact receive the center on 125.15, enjoy your evening. Center on 125.15, Gol Transport S1726. Center Gol Transport S1726 descending to flight level 300.
Gol Transport 1726, good evening. Radar contact.
No litoral sul aparentemente vai descender, só que embaixo da descida, que eles não devem descer com certeza. Temos controle 128 decimal 4, até no nosso decimal 9 não ativou.
Aqui. Chama 1204, Azul 4490, obrigado.
Obrigado. Vocês não autorizaram a falar com o noite, dentro do 40 graus da 19.
Very cold disregard.
Gulf Transport 1726 descend and maintain flight level 210.
Descend and maintain flight level 210 Gol Transport S1726.
881, chame o centro de Recife no 27,5, secundária 128,4.
P3D V5, controle 120.4, alterna 119.9. Centro Recife, Boa Azul 4672, passa 173 ao 340. P3D numa boa ponta. Nível 360 como final, está estimando 2216 em Petrolina, Azul 4672. Sobe então ao 340, estima pouso 2216. Era 4672.
4035, está no controle de Fortaleza, 133,890.
Seja autorizado a linha decolar a partir da Bravo, vento no 40 graus 09 em nós, aqui no 013.
Azul 4503. Sobe ao 380, Azul 4503.
Azul 4482, decolada 25, controle 120, decimal 4, alterna 119,99, fica excelente, voo. 448, 27, controle 204, obrigado,
Então, na verdade, funciona mais ou menos assim. Se a gente tem alguma pane, a gente tem nos manuais, que nem aqui o Non-Normal Procedures, você vê como é rápido, ó. Fire Protection, a gente tem aqui de APU e tem aqui Fire Protection da Engine Fire, em caso de a gente ter alguma pane de motor. Então aqui tem toda a sequência dos itens, que a maioria deles aqui a gente já sabe meio que de cabeça. Então, por exemplo, aqui Auto Throttle, If Engage, Disconnect, ou seja, a gente vai aqui, pum, desconecta o Auto Throttle. E aí vai fazendo, e aí uma pessoa vai confirmando os itens, o outro vai fazendo, entendeu? Thrust Levers, Confirm, a gente vai e desce a manete de potência que está o motor em pane. 3. Start Engine Levers to Cut Off, ou seja, desce essa manete aqui para baixo para cortar o consumo de combustível dentro do motor. Aí logo em seguida, Engine Fire Switch, Confirm, Pull, ou seja, pega essa manete aqui que vai cortar todos os sistemas que estão conectados ao motor, puxa ela para cima e vira ela para o lateral para ela poder ser acionada. Ó, 5 lá, Engine Fire Switch, Engine Overheat Light e If Illuminated, né? Se tiver alguma luz de iluminação aqui da parte de engine. Então vai seguindo toda a sequência, num passo a passo aqui, né, de um checklist. E aí eles vão a todos os passos, né, por exemplo, se continuar com um nível de vibração muito alto, você passa pro passo 7 lá, Isolation Valve, Switch to Close, vem aqui, Close Isolation. E aí vai, né, tem todo um processo com todos os, para você ir mitigando todos os riscos com todos os sistemas de uma vez só, né. E aí tem lá, que nem aqui a gente tem para todos os sistemas da aeronave, né? Por exemplo, todos os sistemas de antigelo, sistema de automação, né? Que é o sistema de piloto automático, comunicação, sistemas elétricos. Se tiver algum problema com flight controls, tá vendo quais são, né? Olha lá, o Runway Unstabilized Trim, que é quando na verdade, é um dos flight controls, né? Que controla, na verdade, o pitch da aeronave. Quando ela sai, às vezes pode ter um problema um problema elétrico na qual ela sai disparando, girando sozinha, por exemplo. Tem todo um processo que é feito também para poder eliminar o risco, entendeu? Então é tudo feito de uma forma você sempre tá ou dentro dos procedimentos normais fazendo todo o checklist, ou realmente quando você tem uma situação anormal, aí sim trabalhar para resolver o máximo possível das panes sem colocar em risco a aeronave nem ninguém a bordo. Então, queira ou não, o simulador acaba sendo uma ferramenta fundamental, né, para a gente poder se manter, né, o máximo possível atualizado nos procedimentos da aeronave e também nos processos de voo em si, né, porque queira ou não, há tanto tempo sem voar, você acaba esquecendo uma série de procedimentos e tal, e aí com o advento do simulador, você acaba ficando por dentro de tudo que está acontecendo. Por exemplo, eu sei que aqui em Jundiaí teve uma alteração de procedimentos recente. Eu falei, pô, mas o que eles mudaram aqui, né? E aí a gente vai consultar, a gente não precisa simplesmente sair com o avião voando. Você vem aqui no simulador e já vê como que ficou a diferença do procedimento que estava do anterior para esse, entendeu? E aí vai. Lá para
check
Recife. Procedimento para pouso lá em Recife. A gente vai cruzar aqui o Romeo Fox 011 a 3.000 pés, inicia a descida até o 1.700 para o 008, segue na aproximação final então, com 110.30 setado aqui no rádio
Speed
já.
Restrictions deleted.
Perfil vertical e perfil horizontal da carta. Contrário, né? Vertical e horizontal.
Gold Transporter 1726, contact Recife for control on 119.5. Have a nice day.
Approach on 119.5, Gold Transporter 1726. Approach Gold Transporter 1726, descending to flight level 120.
Gold Transport S1726, good evening. Radar contact. Gold Transport S1726, altimeter 299er7 at Hartsfield Jackson, Atlanta. I descend and maintain 3,000 feet.
Altimeter 299er7, descend and maintain 3,000 feet. Gold Transport S1726.
Alternação frequência 118.3, está terceira pessoa de check-side.
Coordenação Recife, Mike. Coordenação Recife, Gol no 726. Tá passando 10 mil pés, agora em descida para altitude de fornecimento do procedimento ILS Whisky da pista 18 em Recife, o Whisky, o Papa Gol 1 no 756.
Approach Gold Transport S1726, descending to 3,000 feet.
Gold Transport S1726, radar contact.
Cabin crew, prepare for landing.
Lights on, seat belts on.
Umas 30 milhas para a primeira 72.
approach checklist.
Altimeters.
1013 set.
1013 set. Approach checklist complete.
Então a gente vai fazer todo esse contorno aqui, Romeo Fox 011. Para início do procedimento, só trocar ele aqui que é mais fácil.
Gol 9785, chame o Centro Recife em 126, correção 125 decimal 4, alterna 134 decimal 9.
$190 below. Meu Fox 011 3000 pés, 1700 no 008. Inicia a curva direita até o pouso na final. O aeroporto já está visual aqui já.
Iberia 6AQ4, confirm flying magnet detector. Roger. Inform your maximum for crossing and tell Falcon.
Pode esperar assim nesta frequência, a gente no 013.
And Charlie Golf Lima Papa, confirm.
Recife traffic Go 1726, crossing now 6000 to runway 18. We are expecting runway ILS Whiskey to runway 18. Go 1726.
Goal transport S1726 fly
the BUBA-1A arrival with the ARU transition altimeter 2991 Goal transport S1726.
Goal transport S1726 radar contact.
Flight deck. Okay, thanks. Captain, the cabin is secure.
Thank you.
Transition level. Altimeters reset.
Goal transport S1726 altimeter 2991 cleared for the ILS approach to runway 18 with the RF011 transition at ORBX Global Ferrant.
Altimeter 2991 cleared for the ILS approach to runway 18 with the RF011 transition. Goal transport S1726.
Put a break. Valeu, Eduardo. Boa noite, irmão. Feliz ano novo aí. Flaps 5.
Flaps 5.
Goal transport S1726 descend by the RF011 transition to 1,700 feet.
Descend to 1,700 feet via the RF011 transition. Goal transport S1726.
Goal transport S1726 altimeter 2991 at ORBX Global Ferrant contact tower on 118.35. Enjoy your evening.
Altimeter 2991 tower on 118.35 Goal transport S1726. Tower Goal transport S1726 inbound for ILS approach runway 18.
GOL transport S1726 good evening. Radar contact. Continue ILS to runway 18 call when established on final.
Continue ILS to runway 18 will call when established on final goal transport S17.
Pacific traffic at Delta, go 1723, one final runway 18.
GOL transport S1726 contact tower.
Contact tower on 118.35 goal transport S tower goal transport S1726 inbound for ILS approach runway 18.
GOL transport S1726
Approach
radar
armed.
contact. Cleared for the ILS approach to runway 18.
Cleared for the ILS approach to runway 18 call when established on final. Goal transport S1726.
Checked. Wide slope captured.
Check.
Localizer captured.
Check. Localizer alive.
Checked.
1000 to level.
Roger.
Check.
Stable on final. Go 1726, establish on final. Gear down.
Gear down.
Flaps 15.
Flaps 15.
Azul 4856, Azul 4856, chama o centro de destino 28, vai estar para 26.0. No 468, dentro do 40 graus da nacional, no grau 3, autorizado pouso, 5 livre pouso, secundária 134, o voo 937, decolado espaço 3, controle 120
Go 1726, establish on final. Wide slope captured.
Check.
Missile approach altitude set. Flaps 25.
Flaps 25.
Afirma, apenas para fazer teste na frequência 18.35.
Flaps 30.
Flaps 30.
Landing checklist.
Landing checklist. Engine start switches.
Continues.
Speed brake.
Armed.
Landing gear.
Down.
Flaps.
30 green lights.
Landing checklist complete.
Auto marker, chrono start. I have controls.
You have control.
My throttles.
Check.
inicialmente pro de Malba. Puta 3020, confirme final que solicito 380. Puta 3020, apenas confirme final.
1000 feet, stabilize at the missile approach, altitude set.
Entre no momento até 340, aguarde superior. Azul 4672, o 4672 apresente no centro de China 25
GOL transport S1726 winds are 164 at 7 knots, cleared to land runway 18.
Clear to land runway 18 Goal transport S1726.
Okay, we have our clearance. Any lights going on?
Gol no 727, gol no 727, no centro de China 25.1, no secundário no 23.8.
Approaching minimums.
Plus 100. Runway inside, continue.
100.
150 graus, 06 nós, ao menos.
50. 30. 20. 10.
Speed brake up.
Transport S1726 exit runway when able.
Reversers normal. $60 knots.
Stowed. Auto brake disarmed.
Auto brake disarmed.
Thanks.
Check.
Sete Vitor Lima Delta, China Transponder 5434. Serviço de informação de voo alerta, nível 095 correto para a rota. Informe com a unidade de destino.
Okay, to clean up.
Check.
Estação Recife, São 3526 ali, mantém pista no 8. Quase 4 minutos, velocidade 7, esquerda mais, posição 2.
Go 1726, request taxi. Go 1726, request taxi.
1726 contact receive a ground on 121.85 for taxi clearance.
Ground on 121.85 for taxi clearance. Goal transport S1726.
12185. Go 1726, request taxi.
Aircraft calling ground, say again with your call sign.
Go 1726, request taxi.
Estação portuária, todo estado de direção ingressar na posição 21, entre com o motor 1 desligado.
Go 1726, request taxi.
Então, vai ter que posição na mais.
Continuar na posição 1 mesmo. Não tá pegando no voice control.
Tá bem, então. Estamos cientes.
Lights and doors.
Check.
Ok, reforce ao cerco. Para ingressar, desligado o motor 0. Obrigado.
Cabin crew, disarm doors and cross-check. Doors disarmed, no APU.
Nação Recife, São 3526, inicia rolagem.
We're not at 3 minutes yet.
Okay, starting APU.
Three minutes.
Shutdown procedure. Fuel used. Let me check. 7342. It's 36. Okay, 34. Good. Shutdown checklist.
Shutdown checklist. Fuel pumps
off.
Off. Probe heat auto. Hydraulic panel set. Flaps
up.
Parking brake
released.
Engine start levers
cut off.
Weather radar
off.
Off. Shutdown checklist complete.
Azul 4433 na 33, centro de identificação, mantém nível de voo 390. Quando passar
Okay guys, see you on next flight. Bye bye. Ah, você comentou a respeito das texturas aí, o Short Runway. Na verdade eu tenho sim. As texturas de todos os meus simuladores são bem compactadas para poder utilizar o mínimo de VRAM possível, né? No caso aqui agora a gente está com cenário, mais aeronave, e a gente está usando, tá vendo? 2.7 de VRAM. É o mal do V5, né? Então a gente faz compactação de textura assim.
3026, 3026, reautorizado, seu nível de voo 360.
Saindo aqui, abraço pessoal, até mais. Bom, a gente faz um extended aqui, já são 6h50, não, eu vou jantar, eu vou finalizar aqui, depois a gente faz mais uma outra aí. Um abraço, até mais.